Hey gents, I was just getting my audio working.
All right, welcome, Coy. We are live, and everybody's coming in from the virtual vestibule here. So our attendees are live, and we're going to get started in just one moment here. All right, very good. I think that's enough time for people to funnel in here. So folks, thank you very much for joining us. My name is Zach Hubeck. I'm with MBSI WAV, and I want to thank our special guest today, Tarana Wireless, for filling us in on everything Tarana Wireless as it relates to Canada. So we've got a lot to cover today. I've got a few special guests on the line with me. I'll introduce in just a moment here. But folks, if you're here to learn about all things 6 gigahertz and the latest on ISED approvals, we're going to give that to you. We're going to talk about R&V release, new pricing structure, as well as different promotions that you can take advantage of, including some leasing programs. So we're super excited to bring this webinar to you. With me on the phone today, I've got Nick Grasso, who is Tarana's Senior Sales Director. I've got Varden Amiri, their Sales Engineer. And we also have Coy Bryant and Kevin Rogers from their sales organization who are going to help guide us along. Nick and Varden are going to be doing the majority of the speaking here. And folks, if you do have any questions, please, you've all been muted as a courtesy to our speakers, but if you have any questions, please do pop them in the chat. I'm going to be monitoring those. And I just want to say thank you to a lot of folks on this call are already MBSI WAV customers and Tarana customers of ours. Thank you for trusting us with your business. And for those of you that haven't worked with us quite yet, we look forward to working with you. And then Nick, I will absolutely turn it over to you, sir. Floor is yours.
Thank you, Zach, and appreciate everybody joining us today on this wonderful November afternoon. Got a lot of good stuff to talk about, like Zach said. I guess first update is that currently Tarana and ComSearch, our AFC vendor, are both certified through ISED in Canada. We are just waiting right now for ISED to publish the docs formally. And once that happens, communication with the AFC in Tarana, allowing you to operate in the 6 gigahertz band, will be operational. So we do expect that to happen any day now, but the major hurdle of getting certification through ISED is complete on both sides from Tarana. So we'll talk a little bit more in this presentation about what that means of what UNI bands you can operate in with our 6 gigahertz product. We will definitely talk about some updates on pricing and promotions that Tarana has released that are valid through the end of the year. But this will be a nice overview of our 6 gigahertz product, a refresher for some existing customers, and some new information for some potential new customers out there. So I'll turn it over to Varden, our senior sales engineer, and he can run through some of the specifics of the technology, the products, how it operates, where it operates, and as Zach said, at the end, we'll leave some time for some Q&A as well. So Varden, I'll turn it over to you.
Thank you very much, Nick and Zach. It's great to be here and basically going through some of the Tarana updates with everyone. Thank you for having us and making time in your busy schedule. So Tarana has been around, as some of you may know, for 3 years. What have we done over 3 years? Focusing more on North America, we've grown significantly in 3 years. We have deployments in 47 states, 6 provinces. We've deployed over 11,000 BNs that cover 400 square miles of area, passing over 8 million households, delivering services to 150,000 households. We've done this using multiple bands of operation. In the US, we use a CBRS or 3 gigahertz band. In US and Canada, both 5 gigahertz and 6 gigahertz. You'll see some 6 gigahertz in Canada, the little orange ball. That's because customers have already deployed our 6 gigahertz solution. and they're just waiting for the information to be published in the ISED data set for them to be able to operate in 6 gigahertz. In the meantime, they're operating in the 5 gigahertz until the 6 gigahertz spectrum becomes available. But as you can see, we've done a fantastic job growing in just 3 years. Now, what's new in fixed wireless access? Well, there's a new spectrum that has opened up, which is 6 gigahertz in Canada, and that consists of UNI 5, UNI 6, and UNI 7. Spectrum is good, and why is spectrum good? It is one of the fundamental pieces to getting more capacity on a link. Yes, modulation and all that plays a role, but not as much as bandwidth per carrier. So in order to achieve those gigabit speeds, we need 160 megahertz of channel to be able to deliver gigabit speeds to end customers or residential homes. Now, what we've done here is we've mapped out the 6 gigahertz spectrum, looking at 20 megahertz, 40 megahertz, 80, and 160. Now, notice this includes UNI 6, which is supported in Canada as part of the 6 gigahertz band, but in the US, the UNI 6 is not allocated for fixed wireless access. So that area would have been blank here in the US. But in Canada, you have 100 megahertz more of spectrum. So what does that mean? Well, if you want to operate, gigabit type services, now you have spectrum to do so. But remember, some of this spectrum is already being used by the incumbent for point-to-point. So what ISED has done is said all the spectrum in 6 gigahertz that's not being used may be used through the AFC for fixed wireless access point-to-multipoint. Now, you notice in terms of 160 megahertz of channel, if I look at how Wi-Fi breaks up that spectrum, you have 4 160 megahertz channels, where you have 3 in UNI 5 and 1 in UNI 7. Now, it's not only having a wide channel of 160 megahertz, but also remember that this spectrum for point-to-multipoint is not licensed, right? So multiple operators can use the same spectrum. The AFC will not stop anyone from using it for point-to-multipoint. So therefore, if more than one operator exists in the same coverage area, there's a likelihood that you would need to operate in an environment where there's a lot of interference. Thus, interference results in lower signal to noise ratio, therefore reducing the modulation and giving you lower capacity. So the important thing is having 160 megahertz and operating in a clean, free environment to get that gigabit type speed. So what does that mean? Thus far, a lot of solutions out there that operate in the 6 gigahertz spectrum are Wi-Fi based. So a lot of the vendors have selected Wi-Fi chipsets and placed them into their product to be able to offer those type of performances. But for many of you who have deployed Wi-Fi chip-based solutions, such as 802.11ac or now possibly AX, you will notice that there's some challenges there with the chipset. It's a great solution for Wi-Fi type applications, but may not be adequate for fixed wireless access. One of the things is to deliver gigabit, you need 160 megahertz of spectrum. So some of these Wi-Fi chipsets, support single carrier option only. Means in the chart I showed you on the previous screen, you need to find 160 megahertz of available spectrum not being used by the incumbent point-to-point to be able to take advantage of that to deliver gigabit speeds. Now, typically Wi-Fi chipsets are not intended for fixed wireless access. Therefore, they do not take into consideration interference cancellation. So if you have other operators or even maybe self-interference where you have, blanket deployment or coverage in an area, you may start interfering with yourself because of lack of spectrum or 160 megahertz of channel. And as more and more operators come in or you grow your network, remember, it goes back to the, operating in a interference environment, thus affecting speeds. Therefore, maybe offering gigabit today may not be the case tomorrow. They have some nice tools in there, but they're very basic and intended for Wi-Fi, such as beamforming or multi-user MIMO. Again, intended for like a home environment, office environment, or outdoor kind of campus. Now, when deploying or using 160 megahertz of spectrum, if we look at number of 160 megahertz channels available, each operator would require at least 2 channels, right, to provide a 360-degree coverage. Why? Because of the front to back reuse. They don't do frequency reuse of one. So therefore, you can reuse the spectrum front to back. Therefore, you need at least 260 megahertz of channel to provide gigabit speeds 360 degrees at a given tower. Now, based on the number of 160 megahertz of channels, well, if you have 2 operators, you need all 4 channels. And the minute you have a third operator, you run out of spectrum. It means that's where interference starts. Now, the assumption here is assuming all of the 160 megahertz channels are available and it's contiguous for operators to be able to use. So this is really the complete extreme playing in the favor of the operator, assuming the whole spectrum is allocated only for fixed wireless access point to multipoint, and no incumbent is using the spectrum for licensed point to point. So the other thing with Wi-Fi chipsets is, as you're all probably very familiar with, it's the low subscriber density. And when you start adding more and more subscribers, the overhead increases drastically. So one is limited number of customers you can connect to a Wi-Fi, delivering high capacity. And as you start increasing that, the overall capacity of the AP, which is based on Wi-Fi, starts increasing, therefore reducing the amount of capacity that AP is capable. So therefore, if you look at a lot of the deployments using, for example, Wi-Fi APs, typically you see them anywhere from 10 to 20, best case scenario, 30 customers or 30 clients connected to a single AP to deliver service to them. And as you'll see, the more customers you connect in Wi-Fi, overhead increases drastically. So therefore, difference between 10 or 30 customers connected, the overall capacity at the AP will be lower. So what does this mean? If you take all this into consideration and consider real-world deployments, delivering gigabit speeds with the spectrum that would be available not being used by the incumbent point-to-point, blanket coverage is very slim, right? So that is slim, as well as if you have more and more operators operating in the same markets, it'll be even significantly more challenging because now you have to deal with interference. Now, what has Tarana done? Now, obviously, the ComSearch AFC recently got certified in Canada and is available for use, but we didn't have enough time to do the same analysis for Canada. But in the US, we did an analysis and divided into rural, suburban, and urban environments. So rural being up to 250 homes, suburban 250 to 750 homes per square mile, and anything greater than 750, we assumed it's an urban environment. Now, then we said, okay, let's go dig into the FCC database here in the US and look at all the towers and see what's the probability of getting 160 megahertz channel availability to support up to 2 operators. So not 2, but up to 2. So when we look at that and look at the criteria for the definition of rural, suburban, and urban, we found out that, or it was determined that out of all the towers that were there, there was 30% of the rural areas where you could find 160 megahertz. In suburban, it was 160. It was 52% for the 160 megahertz channel, and in urban, it was 58%. So this assumes up to 2. Now remember, if there's more operators or competition in the area from other operators, you will start interfering. So this is assuming 160 megahertz of channels to support up to 2 operators. Now, this does not mean you can provide blanket coverage, meaning there's a single 160 megahertz channel. Doesn't mean there's more than one. So you may not be able to do 360-degree coverages in some of these locations. So really looking at a corner case of seeing how much 160 megahertz of spectrum is available to support up to 2 operators. Doesn't mean you'll be able to do blanket coverage in those markets. So this is where we are now. What does that mean? Is the 6 gigahertz unusable? No, actually, spectrum is really great. We want more spectrum. All we have to do is, select the right solution that can take advantage of this spectrum such that you can deliver the gigabit type speeds and operate in the environment in the case there's interference in the future. So if you're going to offer gigabit today, you want to be able to offer gigabit speeds tomorrow. Now, before I go to the next step, for those of you who may not be familiar with Tarana, I wanted to go over, next generation fixed wireless access. So what is NGFWA? So NGFWA is having a device at the base and a device at the remote, where it uses many independent radio chains to collect all the energy from the different radios and combine them such that to give you a better signal in terms of when compared to interference. So you think of it as if you have a phone with a 1 bar, you know how your mobile phone will have 1 bar up to 5 bars? Imagine you can take 5 1 bars and add them together to get the 4 or 5 bars that is needed to give you the good signal. Now, this is required to be on both ends of the link. Having a lot of radio chains on one end and only 2 on the remote, that does not help. We need to ensure that both downlink and uplink are capable of doing the same thing, because without an uplink, you don't have a link. You need communication in both directions. What does this multiple radios on both sides do? Well, there's a few things that enables us to do, and is the fundamental building block where we build all the other technologies on top of that. And one of them is beamforming, right? So it allows us to do beamforming from the BN to the RN, or from the RN back to the BN. Now, what does beamforming give us? So big deal. One can do beamforming. Well, the benefits of beamforming is that if we beamform a signal towards a given direction, we can now have multiple beams transmitting at the same time to multiple remote locations, thus multiplying the capacity several times. So in the case of Tarana, each stream can do 400 megabits aggregate. We can support up to 8 streams of data. So that multiplies the capacity to 3.2 gigs. So we can provide 3.2 gigs aggregate to the remotes that are connected. With beamforming, we are also able to do RF nulling. And our RF nulling means that we can null the beam in a given direction, so we can not interfere with ourselves. So we can go ahead and place nulls in everywhere else other than the direction where we're sending the beam. Therefore, we're not listening to that other signal other than the signal of interest. Now, remember, when we do all this, another benefit comes about is the frequency reuse of 1. So the example that I have there, you have a single channel operating on the same frequency that is able to serve a tower. So if you're covering 360 degrees where each BN does 90 degrees, you can use the same spectrum 360 degrees without having to use additional spectrum to do so. And you can do that blanket coverage wide. So you can do that network wide. It doesn't specifically have to be to a tower. You just need to ensure you plan your network properly. In addition to that, next generation fixed wireless access also brings interference cancellation. You notice we call it cancellation and not mitigation, right? Mitigate typically results into poorer performance or lower performance. We actually cancel out interference here. So what you see on the B4 is a constellation of a signal where it's operating in a congested environment, specifically, for example, in the 5 gigahertz, and tomorrow in the 6 gigahertz when it starts getting congested similarly. But when you have an interference cancellation, like in next generation fixed wireless access solutions, which is referred to as ABIC, you see the after effect. You can achieve a 256 QAM constellation, thus delivering full capacity. Even though the environment looks like the before, it's the after effect that allows you to achieve those type of speeds. Well, what are those speeds? What are we really talking about? So what we've decided to do is, we have significant amount of deployments, as I talked to you on the first set of slides. So based on that technology, what are our customers able to deliver to their end customers? So I've divided into two sections. We have the 3 gigahertz and the 5 gigahertz. And I know in Canada, 3 gigahertz, the 365 is not available, but I thought it would be interesting just to show what customers are doing here in the US on CBRS. So it took 50,000 links on each, and then I plotted them. The x-axis is the distance in miles, and the y-axis is the performance. Now remember, these are using 2 carriers only, so 2 by 40 megahertz, and you have the 5 gigahertz on the right-hand side, again using a sample of 50,000 links. If you look at it, anywhere from half a mile all the way to 10 miles, we're delivering an average speed of about 450 at close to half a mile, all the way to roughly about 300 at 10 miles on CBRS. And on 5 gigahertz, it's just under 400 megabits at close to half a mile, and up to about 10 miles of about 150. Now remember, this is average. If you look at the lines protruding from that square, that's the first standard deviation. So that means there are customers, for example, achieving speeds of close to 600 megabits as well. So remember, that's just a single standard deviation from the average, which is the square in the middle. So what I thought would be a little bit more interesting is, how does this look for Canada in the 5 and 6 gigahertz links that have been thus far deployed overall throughout North America? Where if I narrow down to 58,000 links of 5 and 6 gigahertz links, 34% of the links are non-line of sight. Imagine this is a 5 gigahertz and 6 gigahertz solution operating in non-line of sight, which would have been unheard of with legacy fixed wireless access. But yet with next generation fixed wireless access, we are able to achieve that. We also can do 38% in near line of sight, right? So it's not line of sight, but it's near line of sight. It could be obstructed by foliage or building or whatever, but we're still able to deliver those type of capacities as you saw on the previous slide. And then 28% are line of sight. Line of sight has been easy in the past, and many people were able to do it with other types of technologies. Their challenge always came is operating in a congested environment, where you have a next generation fixed wireless access solution that can operate in a congested environment and operate in non-line of sight, near line of sight, as well as line of sight, to deliver the capacities I covered on the previous slide. And just to give you an idea, within the 3 years, we took our top 750 sectors, and there was an average of 80 subs per sector that were connected. And what does that mean? Well, I mean, where would you see this type of performance that I demonstrated on a previous chart, where you had that many customers connected? Now, this does not mean it's our max. We do have BNs with significantly, greater remotes connected to it. We have one particular customer that has 209, offering 100 by 20. Majority of the packages on that BN are 100 by 20, although they do offer 300 megabit packages as well. But just to provide you some insight on the type of subs we see per sector on the average. Now, when looking at spectrum, I decided to jump back to 3 gigahertz here, only because a lot of people think 3 gigahertz is clean. It's a clean environment. Now, when you look at a 50K link sample, you will see that even in CBRS, which is used in the US today, you'll notice that 75% of the links still encounter up to 20 dBs of interference to noise ratio. So it's not clean either, even in CBRS here in the US. And the top 20% is seeing almost up to 35 dBs of interference to noise ratio. So this is an example of even a spectrum where we think it's clean. Tarana is able to cancel out the interfere, operate in that environment with frequency reuse of 1, and deliver the performances in the conditions that we specified and keep customers happy while delivering broadband. So very reliable, high capacity links. So we talked about, spectrum that is now available in Canada, and we talked about next generation fixed wireless access. So how do we bring these two together to be able to continue delivering the capacities we have thus far and more? So one of the things next generation fixed wireless access has done is use not a single 160 megahertz channel. It's going to be very hard to find a single 160 megahertz channel per the AFC that is available to be used by a single operator, right? There's incumbent point-to-point links used by 6 gigahertz. Therefore, it's going to be very hard. So what next generation fixed wireless access solution does is that it doesn't use a single channel. It uses 440 megahertz non-contiguous channels and then aggregates the capacity to give you that 160 megahertz performance, which is a gigabit down, 500 up. So these 440 megahertz channels are independent. You can put them across, various, bands, whether it's UNI 5, 6, or 7. And also, as you'll see later, the 6 gigahertz BN also supports UNI 3 and the STA portion of UNI 4. So you can take advantage in Canada over the 5 UNI bands to distribute the 440 megahertz channel to deliver gigabit speeds all day long. Now, what does that mean? I showed you a chart before for rural, suburban, and urban. Well, what happens if we broke it up into 40 megahertz channels? Now, if we were able to use discontiguous 40 megahertz carriers to get a full 160 megahertz of spectrum, the 30% I showed you before and the 52 and the 58 using Wi-Fi chipsets and keeping everything else the same, except for the condition we've changed is that being able to support greater than 2 operators. So 2 or more, where before it was up to 2, here it's 2 or more. So if we look for 440 megahertz of carriers supporting 2 or more operators in a given market, and we look at rural, suburban, and urban, you'll see that 30% with Tarana next generation fixed wireless access becomes 76%. And for suburban, it becomes 89%. And for urban, becomes 96%. Now, remember before I mentioned that we also support UNI 3 and STA of 4. If I actually consider those as well, these 3 bar graphs become 100%. Means you can literally offer gigabit in all those different types of markets. But to be fair, we're sticking only to 6 gigahertz spectrum available. And remember, in Canada, you have 100 megahertz more, which is the UNI 6, which is not available here in the US for that application. So what have customers done so far in the US? Because Canada, obviously, we're still waiting, as Nick mentioned earlier, for the results to be published so we can actually query an AFC. What are we doing currently in the US? Here is what people are doing in the US. So obviously, 6 gigahertz deployments, commercial deployments started around mid-March. So if you look at the left chart, which assumes using 2 by 40 megahertz, and the right chart assumes using 4 by 40, hence we refer to it as X2. If you notice, the distances is on the X-axis and the Y distances is the performance. Obviously, with 2 carriers on the left side, we are limited to the performance of 2 carriers, which is 800 megabits aggregate. This is just showing the downlink. And you'll see the type of performance that we have captured with one standard deviation. Now going to the right, which is using 440 megahertz carriers, you will notice now the distance is going up to 4 miles, only because obviously you're using 4 carriers, and per AFC and ISED, when you use multiple carriers in the same band, your power drops by 3 dB per carrier, because they consider the total power is what you can use. But even though you see the folks that have deployed Tarana using 4 carriers, 60% of their customers are getting 800 megabits or are capable of getting 800 megabits per second. And you'll notice that there's significantly quite a bit that are even getting gigabit. Now, it doesn't mean they're getting 800 or nothing. You'll notice that all the links in 4 carriers, based on this chart, 100% of them are almost 700 megabits all the way to a gigabit. So if we look at the average link capacity is 847 down, 192 megabits up. So this is what next generation fixed wireless access technology, along with the newly available spectrum in 6 gigahertz, can bring to your customers. Now, what are some people saying? I just thought it's nice to put some of this up in terms of customers using our solution, operating in interference environment, challenging environment, whether it's 5 gigahertz or even CBRS, but just thought I'd share some of that with you from executives of some of these companies. What does that mean? It means we're making life better for people, right? One of the biggest challenges service providers had was churn rate. Here, we're making their life a lot better. We looked across 150,000 links on G1 in 2024 to date, and 99.9% was the uptime on these links. So imagine fixed wireless access, delivering the capacities we demonstrate across 150,000 links. The availability is 99.9%, operating in non-line of sight, near line of sight, as well as line of sight. So as far as deploying in 6 gigahertz or even 5, we believe if you deploy Tarana in 6 gigahertz, it is the best solution to protect your business long term. You don't want to use a legacy fixed wireless access solution that will deliver gigabit today, but as you get more competition, you can't commit to that gigabit that your end customer signed up for or that you offered. So where are we with 6 gigahertz? As far as product goes, well, Tarana 6 gigahertz is available and has been available for quite some time. Obviously, we had to go through certification, as my first chart showed that Canadian customers currently have the 6 gigahertz BN or base node deployed and are just waiting for the 6 gigahertz spectrum to open up. So they're operating the units in 5 gigahertz, but 6 gigahertz is available for you to buy today. The AFC that has been certified that we've partnered with is ComSearch. They have been certified in Canada. The Tarana hardware has been certified to operate in 6 gigahertz. As Nick mentioned, the only thing we're waiting for is the results to be published in the data set. So whenever an BN or an RN makes a request to the AFC, it can go ahead and respond to it because that device would have been published in the data set. Now, the 6 gigahertz, as we mentioned, for those of you who have already deployed Tarana in 5 gigahertz, is backward compatible to UNI 3 and UNI 4. So your investment is still there if you choose to upgrade to 6 gigahertz. And for the ISET certification, we're waiting any day now for it to open up. Once it becomes published, customers can start using it immediately. And I know there'll be some questions around, power levels and all that. We do support the full power level on our 6 gigahertz platform per ISED, which is 36 dBm. And in order to do that on the remote unit, we also have GPS built in to be able to take advantage up to 36 dBm EIRP as well. So we can make the link symmetrical. So we have GPS built in on both parts of the link, ensuring that you have a symmetric, high reliable, robust link with the most amount of power available. We did introduce a new product recently, which is referred to as the RNV, where the V stands for value. And one of the reasons we introduced this product is to help service providers migrate or swap to next generation fixed wireless access at a lower cost, while delivering, same performance using the Tarana chipset. So the question you'll ask is, well, what does this new device look like, and how does it compare to the others? Well, it's roughly around, in terms of dimension, it's more rectangular versus square. But the main differentiation in performance is that it supports only 2 carriers. So it can do 800 megabits aggregate, where the current RN can do 4 carriers. And the RNV is best suited for line of sight and near line of sight type applications, where the current RN can also do non-line of sight. So if you're looking to offer, capacities up to 800 megabits aggregate, and majority of your links are going to be line of sight or near line of sight, for those scenarios, you can go ahead and use the RNV, which supports the upper 5 gig, which is UNI 3 STAF4, and the 6 gigahertz band, which is UNI 5 and 7. 6 will be available shortly for Canadian operators. Now, how does the performance or what are the capability comparisons? We thought the best way to do that is to show it just in a diagram. Mind you, both devices are based on the Tarana chipset. Nothing has changed there. So the fundamental technology is the same. The difference is between the two is that we're using a narrower beam. So the aperture is roughly about 20 degrees. And we do passive interference as well as some active interference as well. So we still do have the interference cancellation. We do still have the nulling and all that in effect. The only difference is that the aperture is a lot narrower. So it's a more focused beam, but yet capable of delivering the same capacities. As far as beam forming, nulling, ABIC, all that is still included in the RNV. For those of you who already have 5 gigahertz deployed, the 6 gigahertz or 5 gigahertz BN can communicate with the following. So if you have a 5 gigahertz BN, it can communicate with the current RNs, which are 5 gigahertz, the 6 gigahertz RN, which operate in UNI 3 and STA4 as well. So there's backward compatibility there. Same thing with the RNV. And if you're deploying the BN 6 gigahertz, you can operate the 5 gigahertz RNs using the UNI 3 and STA4. On the RN6, you can use the UNI 3 STA4 and then the 6 gigahertz band, and same thing for the RNV. So we've made it really simple, backward compatible to ensure that your investment is still intact. What I will do now is pass it over to Nick, and I'll let him discuss with you some of the promotions that we have available to help out with your near future deployments.
Thank you, Varden. Yeah, so appreciate all of that we went through. Some really exciting stuff coming out. We did announce the RNV that Varden went through back at WISPapalooza in October. As Varden said, that product will be available in late Q1 2025. But in the short term, Tarana has released a few promotions to help our customers with some faster adoption of the products. Right now, we've dropped the price pretty significantly on 5 gigahertz. As you can see, you can get a BN for as low as $9,000 USD and an RN as low as $450 USD RN only through the end of the year. We do have, at a limited basis as well, a licensed BN in 6 gigahertz. So you can purchase the BN for $9,000 USD in 6 gigahertz that will be restricted to only 20 RN capacity. So there is a license to unlock it from there for when you get past 20 RNs. That will cost $3,600 USD. But again, for those customers that are looking to enter in a new market or have towers that are maybe less dense, you could enter that with a Tarana BN for only $9,000 USD here through the end of the year as well. Of course, we have our starter kits available. Those are at a pretty significant discount. That includes 1 BN and 5 RNs. That's available for any customer that is their first time purchasing a product in that frequency. Again, through the end of the year, we're also offering what we call our super packs in 5 gigahertz. They're sold in bundles of 2 BNs and 48 RNs, and you can buy up to 4 bundles per customer. One last promotion that we have that we're offering through the end of the year is a very attractive lease and loan options through Leaf Capital. This is a program that's available to all customers in all frequencies. If you're a first-time customer, this is something that you can be participating in, or if you're a customer that is looking to swap out legacy technology in your network from another vendor to Tarana. Those are the two types of customers that can participate in this. There's any volume of BNs and RNs that you'd like to participate in. It's available in either 12 or 24-month leases or 36 or 60-month loans. Tarana is actually going ahead and providing a 5% subsidy on leases or loans that you do through Leaf Capital. The only exceptions of the policy are that a PO must be received to your distributor by December 27th, with the customer taking the delivery on all equipment by December 31st of this year. So again, this promotion on the Leaf Capital is available to anybody looking to swap out legacy technology or any first-time Tarana customers, either in 5 gigahertz or 6 gigahertz at any volume whatsoever. So with that, Zach, I think we left some time here for some Q&A. I don't know if any questions came in while we were talking, but we're more than glad to answer any questions you guys have.
Yeah, quick question was, one of our attendees was interested in the ability to pre-order 6 gigahertz base nodes. I believe we've already been selling 6 gigahertz base nodes in Canada actively. Are there some intricacies there we need to know about, Nick and Varden?
No, like you said, yeah, we've been selling and shipping the gear into Canada and the US since March of this year. The only caveat had been that you weren't allowed to operate in 6 gigahertz until the AFC and our 6 gigahertz spectrum operationally was certified in Canada. So any customer that has been buying, as Varden said, since March and deploying has only been operating in 5 gigahertz. But any day now that we're fully certified through ISPs, they'll be able to operate in 6 gigahertz as well.
All right, awesome. Tom, I hope that answers your question. If not, please do lob another one. Another question we have, gentlemen, will the RNV work on a BN that is broadcasting 4x40 megahertz carriers?
Yes, it will. So the BN, what it will do is it will immediately know the capabilities of the RN, and it will go ahead and only allocate 2 carriers to that RN. Remember, even those RNs that do support 4 carriers, because of link conditions or propagation, the BN can adjust the RN to transmit only using 2 carriers to achieve more gain and to maintain a reliable link. So the answer is yes. The BN can allocate anywhere from 1 all the way to 4 carriers per RN.
Awesome. We've got a question about RNs and BNs. Gentlemen, what's the base speed that is unlocked that's included with those units?
So there's no restriction on capacity on the BN. What happens when you deploy an RN is that at initial installation, you have capacity or the ability to install for max capacity of the radio to determine what the best speed is that you can provide to that home. After a short period of time, the RN is limited to 100 megs in the download. There's no restriction on the upload, but on 100 megs in the download. And then you would just be required to purchase a one-time license key to go to any speed above 100 megs, whether that's 150 megs or whether that's a gig, the highest capability of the radio that can provide. That is a one-time key that must be purchased per RN over 100 megs. And it is a floating key, so it's not tied to a specific serial number or MAC address. If a customer's radio has to come down because it was, compromised or struck by lightning and be replaced, you don't need to procure a new key. You just need to have a corresponding number of license keys to radios that have their SLA set above 100 megs.
Pete sent some feedback immediately, gentlemen. Thank you, and that is awesome.
Always glad to help.
Thank you.
All right. Folks, some good questions so far. Are there any new plans to support the new 3900 to 3980 megahertz band in Canada with the existing 3 gigahertz products? Vardan, why don't you grab that one?
Sure. We at sales in Toronto, we always push. Now, obviously, we got to be able to justify the business case for it. Now, we do look at, future products, and we look at some of the, components we use to achieve those frequencies. I actually, push here internally to try to be able to support that band if it's possible with the chip. But if you're asking if there's any resources or efforts being placed on that currently today, I would have to say no.
Okay. Next question for you guys. Can you use the 6 gigahertz version today with an experimental license from ISED?
Yes, you can. By the time you order the 6 gig and get the experimental, I'm hoping ISED would have already published the information they have so we can operate in 6 gig. But if you have it handy and you want to use it, yes, you can.
All right. From your mouth to God's ears, Vardan. That's not what anybody typed in. It's something I said.
I know, Zach. I know you well.
I did pick up on some hints though early on. Justin was saying he was impatiently waiting for that AFC, and I think the crowd agrees. Okay. Folks, last call for questions. Either use the chat, use the Q&A. Here we go. Here's another one that just came in. I may have missed it, but when will the RNV be available, guys?
Yeah, that's end of Q1 2025. So expect late March timeframe.
All right. But it can be pre-ordered today, right, guys? Just not shipping readily. Yeah?
Very, very, for a brief period of time during WISPapalooza, there was a option to do a pre-order. I do not think we are taking pre-orders at this time, Zach, but I will clarify that, and you'll be the first to know to let the customers know if they can or can't.
Okay, wonderful. Very good. I am scouring the chat and Q&A as we speak, gentlemen. Doesn't look like anything else is coming in. Guys, thanks for the valuable session here. Folks, we are going to send over this recording to all of you guys. You can receive a copy of the presentation as well. And, on behalf of MBSI WAV, I want to thank Tarana Wireless for the great partnership. I want to thank all of our customers that have joined today. Thank you guys for trusting us with your business. And we look forward to more great things in Canada. Let's go, Team ISED.
Yes.
Thanks, Zach. Appreciate it.
Thank you, everyone. Thank you, Zach.
All right,
Have a great day. Thank you.
You too. Bye-bye.
Bye.
Bye.
Sorry, boys. For the sake of the recording, and we've got some folks dropping off here, we did get one last question that came in. Let's answer this before the recording stops. How does non-line of sight compare to TV white space, guys?
Very different. The non-line of sight with TV white space is only because of its lower frequency. With Tarana, we actually have the distributed massive MIMO that handles the non-line of sight. So if you're going through foliage, TV white space would do better. If you're going, building reflection, Tarana will probably do better.
All right. And Tarana does not have that big gangly TV white space form factor that we've seen in the market as well, right, boys?
Correct. And you can't get the capacities with TV white space as you can with Tarana.
Channel sizes are much, much smaller.
Yeah.
All right. That was a great, robust answer. Thank you, gentlemen. This has been a great session. We'll see you around.
Thank you, Zach.
All right.
Yep.
Have a great day.
Bye.
You too.